So hello, everyone. We are now in the second lecture of week 10, which makes this lecture number 20. We're now 2/3 done with the course. We're gonna finish the normal model today. And as I discussed with the class over the last few minutes, the test will be next week, and it will cover chapters 7 through 14. We will finish chapter 14 today and not move on to 15. And then we will do we'll have a review on Monday of next week, and then and then on Wednesday of next week we'll move on to the next chapter. Namira is here. Welcome, Namira. Remind me at the end because I've already started. Okay, so let's see, where did we get up to last time? We did the z-scores, we did the t-scores, we did the percentiles, we did this Taylor Swift video thing. I think we even did this one, didn't we?
Yeah, we stopped at slide 13.
Okay, so t-scores. Okay, so t-scores, right? I think we started t-scores, but we didn't quite finish it, so we might as well go back to t-scores. So let's just recap again what a z-score is. A z-score is essentially how many standard deviations you fall away from the mean. If your z-score is 0, that means you fall right at the center, right at the mean. If your z-score is 1, you are 1 standard deviation to the right of the mean. If your z-score is 2, you are 2 standard deviations away from the mean in that direction, and -1 means to the left, and -2 means, and so on. So you get a z-score that's negative, and a lot of people have a very difficult time with that. Oh my God, I got a negative score. What does that mean? So to alleviate this concern, sometimes something called a t-score is used instead. Now, this doesn't stop you from having to first compute the z-score, because you first must get the z-score, and only once you have the z-score can you then go ahead and compute the t-score. Okay, so how do we compute a t-score? We will first compute the z-score. We then multiply the z-score by 10 and then add 50. Okay, we multiply it by 10 and then add 50. That's just a formula. Okay, you might say, why is that formula in place? And that's a great question, why that formula is in place. It's just the way it is. Okay, that formula is just the formula for the t-score. Okay. So the first question is, what is the mean and standard deviation of the t-score? Well, if the mean of a z-score is 0, doesn't it seem reasonable that the mean of a z-score should be what you get when you plug in 0 for your z-score? And when you plug in 0 for your z-score, what do you get? If your z-score is 0, what do you get? Sorry?
50.
You get 50, right? So doesn't it seem reasonable that the mean for the t-score is 50?
It does.
It does. Okay, and in fact, it is. It's right here. Okay, and in fact, it's right here. The next question is, what is the standard deviation of the t-score? Well, if you look at the graph, it should kind of be a little bit obvious what the standard deviation is. Because remember, we know that in the middle of the curve, it looks kind of like a U, or an upside down U more specifically. And then when you go further to the right or left, it eventually becomes more like a regular side up U. And that point where we change from one to the other is 1 deviation out, 1 standard deviation. From the looks of this graph, what does that equal to?
From 40 to 60?
Well, 40 to 60 would be 1 deviation left and 1 deviation right, right?
Would that be 10?
So 10. So the standard deviation for t-scores is 10. Okay, 50 to 60, 50 to 40, that's 1 deviation left, 1 deviation right. 70 is 2 deviations to the right, and so on. Okay, so these are the t-scores. These are the standard deviation and means for the t-scores. Okay, so let's just do an example of this. Scores on the Wechsler Intelligence Scale for Children, the WISC-4, because the first 3 were bad enough, are normally, see, it's still funny, right? Are normally distributed with a mean of 100 and a standard deviation of 15. compute the t-score for an IQ score of 75. So what's the first thing we must do to compute the t-score for an IQ score of 75? We first must compute the z-score for a score of 75. So how do I compute the z-score? Well, we have a formula for that. Anyone remember what the formula for the z-score was? Z equals our raw data, which in our case is what? What's our raw data here?
75.
75, our raw data.
Minus the mean.
Minus the mean, which is what?
Uh,
Was it 50? Right?
100
100,
Oh shoot.
over the standard deviation, which is
Which is?
15.
15.
Which is
50?
15. Which is 15, right?
Wait, why is it 15?
Because they
Oh,
told
I
us it's
see it.
15, right?
Never mind.
The best reason possible, because they told me it was, right? No computations necessary. It's like, hey, here it is. So what's our z-score?
Professor,
Yes,
when you say raw data, is that the same as saying the data point?
yeah,
Okay.
yeah. The raw data means the data itself without any manipulations or adornments of any kind. Just here's your value. Okay, no interpretation, no scale factors and changing anything. Just here's your data. Okay.
Okay.
So what do we get for this? Equals what?
1.6.
1.6 repeating.
That can't be
Negative.
right. Negative, very important. Negative 1.6, 70, negative 25 over 15. It should be repeating.
I said repeating.
No, it shouldn't be repeating.
What?
I don't think 25 over 15. Oh, wait. No, I'm sorry. It does. I apologize. It does. 25 over 15 is 5/3. Okay. Now that we have the z-score, how do we go ahead and compute the t-score?
Plug it into the equation.
Hey, can't beat that. The only thing better than being given it yourself is being given a formula to compute it. So what does the formula say? The formula says take the z-score, which we just computed, multiply it by 10, and then add 50. So if we go ahead and do that, take the formula, take the z-score, multiply by 10, and then add 50, what do we get? What's negative 1.6 bar plus times 10?
Negative 16.
Negative 16.6 bar, which when we add to 50 gives us what?
34.
Approximately 34, right? I think it's 33.3 bar. Is that correct? Yes?
I rounded, so I don't know.
You round, oh my God, you rounded. Horrible, horrible. Negative 25 over 15 times 10 plus 50, 33.3 bar it is, yes.
Like for a test, would you want us to do the repeating or would you want us to round to like the nearest 10th or something?
I always tell my students, as I'm telling you, you keep every decimal possible until the very end of the problem. And only then do you round. So because the z-score was not the end of the problem, I would use negative 1.66666666666, whatever my calculator gives me. I would then use that, multiply that by 10, and then add 50. And then at the end, when you get 33.3 bar, if you want to say, okay, this is about 33.3, that's fine. But if you round in the beginning, then your answers are going to be a little off from where they should be. Does that make sense?
Yes.
Okay, next question.
Professor, sorry, I have a question.
Yeah.
I got from a t-score, I got exactly 34. Why did you get 33.3
Because
repeated?
you probably
Oh,
used the rounded version of this, right?
okay, got it. Yeah.
Now, what if the t-score was 40 and someone says, oh, that's a great t-score. What was your z-score? So let's work backwards. We know that t in general is what formula? Is 10 times z plus 50, correct? 10 times z plus 50. Oh, that didn't work at all. How do I kind of grab it and move it? Is there a way to doing that? Select.
No.
I don't know what's happening. Okay, whatever. I'll just do it again. So 10 times Z plus 50, right? So if 40 equals 10 times Z plus 50, and I say I would like to solve for Z, what do? What will be the first step mathematically?
Subtract 50 from both sides.
Subtract 50 from both sides. So you get negative 10 is equal to 10Z. And then what would I do?
Divide by 10.
And what do I get? Z is equal to
-1.
-1. So there's us converting from t-scores to z-scores and back.
So then the z-score would be
-1.
-15 from 100.
Well, no.
Oh,
So
no,
so it's a good question. So the z-score is -1.
Okay.
The question that you might ask as a follow-up is, what is your data point? What was my actual score if my z-score was -1?
Like -9.
Huh? What was my raw data if my z-score was -1?
You subtract from the mean, which was 100, you go 15 less.
Wouldn't
So
it
what
be
do I get?
over -15?
Well, the mean's 100.
85.
85. Right? The mean is 100, right? With a deviation of 15. If my z-score is -1, that means I'm one deviation down from the mean. If my mean's 100 with a deviation of 15, that means I'm at 85. Does that make sense?
Yeah.
Questions on that?
Wait, say that again.
Which part?
The x equals 85,
Well, what's my z-score?
-1.
What does that mean to have a z-score of -1?
Well, is that when you move to the left or something?
No, just what does it mean conceptually to have a z-score of -1?
How did you get -1?
We solved. We had our t-score, 40 equals 10z plus 50, subtracted 50 on both sides.
Try this.
And then divided by 10. That's my dinner, guys.
What is that?
Chocolate mint cookie crisp bar.
Is it a protein bar?
Huh?
Is it a protein bar?
Yeah, basically 11 grams of protein.
The way you brew that, you wasn't too happy about that.
Well, I miss my big meals that I like to have.
But you're doing a great job so far. Just keep it up.
Yeah, down 15 pounds so far.
Hey,
Yeah, it's all water weight, doesn't really count.
It counts.
it's true. But it's still 15 pounds less.
Oh, 15 pounds less.
How is it?
There.
Huh?
How
It's
is it?
It's horrible.
not, it's not about the end goal. It's not about the end point. It's about the journey.
No, it's about the end. All right. So anyway, so we solved for the z-score. So a z-score of -1 means that my data point is exactly one standard deviation beneath the mean. Well, if the mean's 100 and my standard deviation size is 15, then one standard deviation less than 100 is 85. Lose weight for me. Because kick butt. Thank you, Alex. That was great. That was nice. So, as I like to tell my students, when they want to take the easy way out, I say math is not a spectator sport. All right, to do well at math, you got to participate. Okay, and I use the analogy that you can't watch other people work out to lose weight. I wish you could. I would spend all day in the gym, not actually working out myself, just watching them. Okay, I would never actually work out myself. That's just silly. But the point is that you got to put in the work if you want to get the rewards, right? So it's like losing weight with me. I want to be thin. I want to be in shape. It's just the amount of work to get there is always so daunting. It's just easier not to. Okay, so the goal is to overcome that and work at it and work. Oh, I'm giving myself a pep talk here. And even though I really don't want to. But anyways, okay, so the Z-score is, yeah, question, go ahead.
Yeah, so then the answer for the bottom one would just be the Z equals -1, or we also got to show the X equals 8.
Well, they asked what the Z-score was. I followed it up. I said, okay, what's my data point? Let's take it one step further.
Okay.
Right? And here, I could do the same thing. This one's a little more challenging. It's not so obvious what the answer is. How would I figure out my data point in this example? Motivation Wednesday. That's a good one. Motivation Wednesday.
Would you set 33.3 bar equal to 10 times Z plus 50?
Well, we already did that. I mean,
No.
that's how we got T.
Oh,
But if I want my data, I don't want to go to T. I want to go back to Z because Z is what connects the data to T. Z and X are connected. Z and T are connected. We don't have a connection between X and T directly.
So would that be negative 1.6 repeated deviation away from 100?
Yes.
Does that make sense or no?
Yeah, but we want to calculate that. So what's the formula? The formula for Z in relation to T is what? Negative 1.6 bar equals. What's the connection between Z and X? What?
Is it the percent? No.
A motivational speaker? No. Come on. Data point minus mean.
Yeah.
Divided by the standard deviation
Oh, I get it.
is the Z-score.
Okay, it makes sense.
So all you got to do is multiply these, cross multiply. So negative 1.6 bar times 15. You get negative 25 equals X minus 100. And therefore, what is X?
75.
And therefore, X is equal to 75, right? So Z is the connection between T and your data point itself. Does that make sense?
Yeah.
I have a question. Do
Yeah.
you cross multiply the X minus 100 by anything?
Well, technically by 1,
Okay, thank you.
right? When you cross multiply this times this equals this times this, you can put it up at 1. Okay, so we finished chapter 14 today. That's all I wanted to cover today. We're going to end early. Unless you guys want to go to the next chapter, I'm totally
Oh,
okay with
we're
that.
okay.
No,
been working too hard
I'm
today.
already in like mental breakdown mode over the fact that we're having a test next week, so I think we're good.
Okay. Well, then we will call it here. Can we talk about the Dodgers?
Yes, Adrian. Yes, we can.
Dodgers. How about we talk about the Rays pulling their best pitcher when he's pitching a dominant game, only to completely.
You sound disappointed.
No, it's just if you want to win, that's great, but you want to win against the best possible opponents. You want to win against. Oh, can we go over the quiz? What quiz? We had a quiz?
It's the analytics.
Huh?
I said that decision was all analytics.
Yeah, no, I mean, listen, if it would have worked, everyone would be praising it. If it doesn't work, everyone thinks it's the worst. I don't know. Okay, so it's all Moneyball's fault. Which quiz are we talking about? The last one?
Yeah, on 11, quiz 5.
Let me find it. Hold on. So I can get rid of this. That's done with. And quiz 5. Okay. So let's load it up. And I'll put up all the solutions to all the I'll put up the solutions to all of the homeworks up as well. So you have access to that. Okay, here we go. A child in your second grade class is at the 74th percentile on the California Standardized Reading Test for second graders. Write a brief explanation for her parents. Essentially, it's just your child scores better than 74% of second graders. Or out of every 100 second graders, 74 will score worse than your child and 24 will score better. There's multiple ways you can do it. Essentially, it's the idea that on the grand scheme of things, of second graders, 74% do worse, 26% do better. That's the 74th percentile. People who said anything like your child scored a 74th% on the test, you're missing the whole point. Okay, that was no credit, but I think very few, if any, did that. I seem to recall they're not, I mean, only one or two did that, I think. All right, question 2. The following cumulative percentile graph shows the number of golfers by age for a certain golf club. About what percentage of the golfers are 19 years old or less? So I'm going to go to 19, which is right here. And I'm going to draw a line, hopefully directly across. And it looks like I get something along the lines of 15%, something in that vicinity. So 15% of the club's golfers are 19 or less. The 60th percentile, the next one, I go to the 60th percentile. That seems to be 59. The approximate median age, yes, the 50th percentile. That seems to be I don't know, 55, give or take. These are all approximations. As long as you're in the ballpark, I gave you credit.
Professor, what was part A again?
About 15%,
Okay.
give or take. And then I said, then the question was number 3, given a set of data, your students are trying to find the median. One of the students says the median is 3 because it's right in the middle. Is the student right? And the answer is no, the student is an idiot because, I'm just joking. The student is wrong because you have to first line them up in order from lowest to highest. And when you do that, 6 ends up being the median. For this one, number 4, give it the following data set. It says, notice that the numbers are already in order, which is very nice. It says, find the 5-number summary. So you first count how many there are. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. There's 20 of them. 5, 6, 7, 8, 9, 10. So the median is between these two numbers. So the median is 13. And then you look at the numbers to the left, there's 10 of them. So the median is between those two. I mean, the Q1 is between those two, it's 6.5. And between those two, it's 20. The max is, of course, just 28. And the min is, of course, just 2. And then the box plot is essentially just, right, 28 here and 20 here. And the median is 13 and 6.5 and 2. Make sense? I hope so. All right. So
Yes, thank you.
okay, so we'll have the test next weekend and we'll call it a day. So I hope you all have a good weekend. Study hard and we will, I'll stop recording now because we're